Alright, so one last example, sketching the graph of y equals tan of pi x. So in this case, our period, again, is pi on n. Intercepts occur at multiples of pi on n, and the asymptotes at multiples of pi on 2n. Now in this case, n is a bit funny. Well, n is the thing in front of the x, so in this case, n is actually just pi. So my period is pi on pi, which is just 1. My intercepts, that means they occur at multiples of 1. So that means 0, 1, 2, 3, and so forth. So essentially this is the graph without the pi's. And then finally multiples of pi on 2n. If we want to see that written out, that's pi on 2 pi. Those cancel out. That's just multiples of 1/2. Okay, so that's going to be at 1/2, 3/2, 5/2, and so forth. So sorry, these are the odd multiples of pi on 2n. Okay, so not at the integer values, but at the half values in between. So now we can put this on our graph. Okay. So again, these graphs, without a scale, they would all look the same, so the scale is extremely important. So I'll start by going 1/2, 1, 3/2, 2, and we'll go backwards as well. -1/2, -1, -3/2, and -2. So we got a really full picture here. Again, please do use a ruler, even though I haven't on here. It's just hard to show with a ruler. So I'm going to start by putting on my asymptotes. So those are occurring at the half values. And then I'll draw the actual graph in red. So I've got my zeros at integers. I start at 0. I always remember I start going up at 0 because that quadrant is the A of the cast rule, so they're all positive. And then I switch to negative. I start going up, but when I get to 90 degrees, my x values get negative, so that switches signs abruptly at the asymptote. And this will just be 1/2 of the graph. And I really apologize for how wobbly these graphs are. Hopefully you still can get the idea. So that's y equals tan of pi x. So same shape. Again, it's all about the labels that make the difference. Here we go.